When China's defense industry begins mass-producing a stealth drone that costs only tens of thousands of dollars yet can penetrate air defense systems 1,200 kilometers deep at a supersonic speed of Mach 1.8, does the world's existing air defense logic need to be fundamentally rewritten? What we're discussing today isn't a conceptual model in a lab, nor a static exhibit at the Zhuhai Airshow meant solely for display. It's a genuinely dangerous piece of equipment that's already out in the open and has entered mass production, the TM300 long-range strike drone. Just recently, China publicly unveiled this new TM300 long-range strike drone for the first time. According to multiple sources, this model has now moved beyond the prototype stage and officially entered mass production. The reason why Ukraine's Defense Express website used the term extremely dangerous in its headline is that the TM300's technical specifications combine several of the most challenging attributes for modern conventional air defense systems, all built upon the Chinese defense industry's astonishing cost control and mass production capabilities. Let's first examine a set of key specifications. The TM300 boasts a maximum range of an astonishing 1,200 kilometers, meaning it can be launched from deep rear bases to strike critical infrastructure, command centers, or logistics nodes far from the front lines. While the launch platform itself remains completely outside the range of enemy tactical fire, its payload capacity is 100 kilograms. While this warhead weight might not seem particularly impressive for a traditional aerial bomb, for a munition designed to penetrate dense air defense networks and deliver precision strikes, a 100-kilogram high-explosive or armor-piercing warhead is more than sufficient to destroy radar stations, missile launchers, reinforced hangars, or the superstructures of moored warships. Furthermore, the TM300 is equipped with two jet engines, providing it with formidable propulsion. Speaking of power, we must mention the TM300's most alarming statistic. Its maximum flight speed can reach Mach 1.8. This is no longer the sluggish subsonic cruise of traditional weapons, but rather an aerial hunter capable of breaking the sound barrier. You might ask, is Mach 1.8 fast for an interceptor? It certainly isn't the fastest, but within the realm of suicide drones or cruise missiles, this is an extremely threatening speed range. Although it is unlikely that such aircraft can maintain such high speeds throughout their entire flight, especially when maneuvering in the dense atmosphere at low altitudes, the TM300 still possesses the capability to fly at supersonic speeds during its terminal sprint phase, or high-altitude cruise phase. What does this capability mean? It means that the reaction window for air defense systems is compressed to the absolute limit. Traditional slow-flying drones, such as the Iranian-made Witness 136, cause significant trouble by relying on low-altitude flight and numerical superiority, but their speeds are only around 100 to 200 kilometers per hour. Once detected by radar, even outdated anti-aircraft guns or shoulder-fired missiles have ample time to prepare for interception. But when faced with a 1.8 Mach surprise attack, the entire process, from radar detection and identification to fire control calculations and missile launch, must be measured in seconds. If the air defense system hesitates even slightly, or the operator shows the slightest delay, the TM300 will have already streaked past the defense zone, hurtling straight toward its target. However, speed alone is not enough to label a drone extremely dangerous. What truly sets the TM300 apart from other long-range strike weapons is its inherent stealth design. According to disclosed information, the TM300 was designed with radar suppression in mind from the outset. Although there are currently no precise figures regarding its radar cross-section, its external features and air intake layout suggest that its radar signature is far lower than that of conventional drones or older cruise missiles. The combination of low detectability and supersonic penetration makes it extremely difficult for defenders to establish an effective interception chain on the modern battlefield. The long-range early warning radar you've spent a fortune on will likely only be able to detect it at extremely close range. By the time your medium-range air defense missiles enter the terminal guidance phase, it may have already struck its target and departed. Even more critical is that the TM300 is capable of flying covertly at low altitudes. Flying at low altitude allows it to exploit the curvature of the Earth and terrain clutter to block radar lines of sight. Combined with its stealthy design, this keeps it in a semi-stealth, or even full stealth, state for the vast majority of its flight path. By the time ground observers hear the piercing roar of its jet engines, it is often already too late to mount any effective response. This method of penetration poses a direct and severe challenge to existing layered air defense systems. Having discussed the combination of speed and stealth, we must now turn our attention to the keyword behind the TM300 that truly has the global defense community on edge: low cost, large-scale mass production. When reporting on this weapon, many Western media outlets cannot help but express anxiety regarding its production capacity. As is well known, China possesses an unparalleled advantage in weapons manufacturing, mass production at low cost. This is not merely due to cheap labor, but is underpinned by an extremely well-developed supply chain system, mature manufacturing processes, and a vast civilian industrial base. Recall China's previously unveiled Phylong 300D, a suicide drone designed with the witness concept in mind. According to foreign media reports, its cost was reduced to just around $10,000. Even the YKJ-1000 hypersonic missile, with its cutting-edge performance, was publicly priced at just $99,000. This industrial magic, making cutting-edge technology widely accessible at rock-bottom prices, is the deepest nightmare of the Western military-industrial complex. Although the specific unit price of the TM300 has not yet been disclosed, based on the past experience and practices of China's defense industry, its price will undoubtedly remain at an extremely competitive low level, and it will be mass-produced on a massive scale without hesitation. Exchanging an interceptor missile costing hundreds of thousands or even millions of dollars for a TM300 that may cost only 1/10 or even less of that price is a trade-off that no country's defense budget can sustain in the long term. Experience on the Russia-Ukraine battlefield has already profoundly demonstrated this. The Witness 136 drones supplied by Iran to Russia have a unit cost of approximately $20,000 to $35,000, while a single interception using Israel's Iron Dome interceptor costs as much as $100,000. And if air-to-air missiles are deployed for interception, the cost soars to $400,000 to $600,000. This asymmetric cost burden is fundamentally undermining the sustainability of traditional air defense systems. Since the TM300's speed and stealth capabilities far exceed those of the Witness series, defenders will need to deploy more expensive and advanced medium to long-range air defense systems to counter it, causing the economic cost of each interception to multiply exponentially. The TM300 is not merely an iterative upgrade of a single weapon model, but a paradigm shift in strike logic. When four key elements, a 1,200 km standoff range, a terminal velocity of Mach 1.8, a low observable design, and unit costs controlled to extremely low levels, are integrated into a single platform, the traditional layered air defense kill chain faces structural pressure, leading to a decline in effectiveness. The drastic narrowing of the interception window and the exponential rise in interception costs will force defenders to make strategic compromises in resource allocation and fire channel management that were previously unimaginable. It is foreseeable that, with the large-scale deployment of such systems, the survival logic of high-value fixed targets and mobile formations will be forced to be redefined, and the balance of power in anti-access and area denial operations is quietly shifting due to the maturation of these asymmetric technologies.